So now we will do Anova from basic code. We write the code ourselves. We will not use any R pre-prepared functions in our. Right? So let's take a data set with different number of elements. Let's say X is one group is X. Let's say 575832. Y is a little bit larger, and then Z is a little bit number. So then let's just put it in data frames. Let's just call it DF. DF is equal to data.frame. And then we just put this in, and then we'll say X, Y, Z. That's DF. So if you do DF downstairs, so DF downstairs should give you three things: X, Y, and Z. So again, we stack the data frame the way you want to stack it. Let's this time stack it as 1:3, let's say. So let's do that. So we go a little different. So I think let's try that. Let's do stack. And let's stack it. Let's stack it like this. Same way values and INDs. So X is a category, and then so this is like a little bit more specific command for stacking, and then so the data frame is a stacked format. So now let's try and do a little bit fancy way of box plotting it again. So let's just do let's use ggplot and plot it. Let's say so. Let's just say let's do library. Let's do a little bit of ggplot after a long time. Let's do library ggplot 2. Let's run that. Let's just settle in, and then let's just do a ggplot of, let's say, data equal to df. Like data equal to, let's say, stack of something. Let's say take this. Let's say df1. Let's say df1, and let's keep the aesthetics simple. Let's say x is the IND, and let's say y is the values, and let's just do a box plot. So geom underscore box plot, and then that's it. That's all we do, right? And then let's forget labels. Let's not do it right now. Just do a simple ggplot. This is what happens. Let's see. Is it okay? Then I'll have to. So it should df1 or I shouldn't do df1. Sorry about that. df1, and then let's do like gplot geom. Geom plus. What's going on? So this is like a geom underscore, right? Geom underscore. So that should give you a box plot. So clearly now again we have x, or maybe x, y is I'm not entered. Let's keep the old one. Let's say x is this, y is this, z is this. One similarly similar like the other one as well. X and z look similar, but y is very different. Very good. So now I want to define this what do you call this sum of squares, right? I want to stack it. After I want to do R, I want to do within sum of squares, between sum of squares, and so on. So let's do the between sum of squares first, within the groups. Let's do it. Not between the groups, sorry. So how do I do this? I take the x guy, subtract its mean, and square it, right? So let's call it as df1 $x. That's the x guy. So maybe I do df $x. So the first guy minus mean of df $x. Then this I wanted the whole square, right? If I do this, start do the same. That's good. Let's call this as df $x diff square. Let's say that's this one, and then I do the same thing for the y and the z. This is this. Fine. Let's do z. Z. This, and this. There you go. This is done. So now I've added this to data frames. Suppose I put df and I type it in, I should get this the two extra columns, the x1, the y1, and the three extra columns. So you'll have to square the differences between the individual group values with the mean. That's what I've got there. Very good. So to calculate the sum of within squares, I just sum of each of the columns. That's all I do, right? So I just go and take in I go and if I do sum SSW is equal to I just go sum of, I go df dollar x, this one, plus sum of df dollar y, this one, plus sum of df dollar z. That's I sum all these three squares. That's what that's one. SSW. So if I do SSW, it should give me exactly 64. That's the sum of squares that I get. There you go. Sum of squares within I get this. So then to do the between one, I do the total sum of squares. So again, I have taken df1 to be the stacked one. So then I just do the total one. Total one should be easier, right? Just do I first do the mean minus this one. So I just do the I just do again, let's call it as, let's give it a name, maybe let's call it as total, let's see, total diff square is equal to, let's say, or let's say diff square is equal to, let's say diff square is equal to, I have to just take all the values and subtract the mean and take the square, right? So let's do that. Let's just do mean of maybe what's it called, df df1 dollar values minus df1 dollar values, and whole square is just whole square. Each of the thing, and then I have to sum all of them up, right? So I have to do sum of this. So let's say, let's call this, so doing this nonsense, let's do SST is equal to the sum of this guy. This whole percentage. So that total sum of squares. So let's do that. Let's see what this is. Let's do this. And let's do SST, and then let's do that. So I get 167.33. That's the total sum of squares. Okay. And what's the sum of square between groups? So sum of square SSB is equal to what? SST minus SSW. Let's do that. And let's do SSB. That gives me 103.33. So let's do that. Let's just write this down. This is sum of squares within. Sum of squares within. Then this is sum of squares total. And this is sum of squares between. Very good. So then what do I have to do now? What is the F statistic? I have to calculate degrees of freedom first. The degree of freedom is quite easy, right? Because of X, Y, and Z, and I subtract 1. So the degree of freedom SSB is going to be equal to 1. That is just going to be 3 minus 1, right? So 3 is the total 1 minus 1. That's easy to see, right? Then the number of rows is over. The number of rows is length of the data frame minus this guy. Let's just do. So degree of freedom for SSW, or SSW is going to be what? It's going to be length of the data frame, which is DF1, or n rows you can take. The n rows you can take, and then mean n row, and then minus 3 of them. Let's do that. So this is 2, this one is this. Let's do DF. SSB is 2, DF, SSW is 2. Exactly what we have. Right? Very good. So now, how do you do the F value? The F value, so this is degrees of freedom. Let's write down the degrees of freedom. How do the F values? F value, you do the mean sum of squares first. Let's do the mean sum of squares. So corresponding mean sum of squares. Mean sum of squares. So what do you do first? For this guy, you do, so let's see, for the mean, let's say SSB is equal to what? SSB divided by DF SSB, and MSSW is again equal to the same thing. So it's equal to SSW divided by DF SSW. Right? So M is this is what we get. And what's the F statistic? The F statistic is MSSB by M. So let's go to F statistic. The F statistic is F is equal to MSSB divided by MSSW. To F, let's calculate what F looks like. F looks like 9.687. That's the F value. So now you have to think, you reject the null hypothesis or not. So what do you have to do? You have to find the critical value or the alpha value for F. So let's say we fix P as level of significance alpha as, let's say, as 0.05. And we have to compute the lower tail probability. We have to compute the chance that that the critical value do, right? So let's do that. Let's just see this. So QF is equal to, so let's say, let's call the P value, let's call it the P value is equal to the QF of P. The P is 0.05, so P equal to 0.05. And that's what QF does. And then DF1 is equal to 3 that we have here, right? This is equal to 3. And or let's just call it as DFSSW, or DF2, so DFSSW, sorry, and DF2 is equal to DFSSW, which is 12 for us, and then we want lower dot tail equal to false. This is what we want. This is what we do the test. Let's do that. Let's do p-value, and let's do p-value. So it's 3.88. This is quite like so we will be able to so this is the F value. So this is the F value. So this is the F value, critical value. Sorry about that, the critical value. So it's quite large, so we reject the null hypothesis. So you can also do the F table, that's 2R, but use the alternative QF function to find the critical value. So the critical value is 3.88, and it's quite large too, so we do not have this. Very good. Okay, I'll stop for this one and then get the. So there's another way of rejecting the critical value is quite large. So we can reject numbers. But all the things are the same. So now we can also do the whole thing. Anova, let's do the whole thing with an using inbuilt function. It's using inbuilt function like before. So same data set, right? So let's take the same data set. Let's go back up. So our DF is the same. Our stacked is also the same. There's nothing to be done. DF1. So let's do Anova. Let's see if we get the same answer. Anova of what do we get? We have to take values. How to do values still independent? That's what I did before. Let's do Anova of let's say LM of values versus I and D, not independent again. I'm sorry, I and D, and then data is equal to DF1. Data equal to DF. Spread that. Let's do that. So what happened now? Values is not there. What happened? What DF1 is not there? I thought DF1. Oh, DF1 is not do here. I did DF1, right? Let's do DF1. Very good. Values is there. Very good. Did I make a mistake here? No, I did the same thing. Oh, sorry. The data should be inside the thing. So now get the same thing. Get like so 9.65, and p value is very, very small. So you get what happens. P value is very, very small. The F value we got 9 point, which is the same as before. The F value also before we got 9.687, same. 687. Sum of squares also similar. We get some degrees and 2 and 12. We did the same thing. Very nice. Quite cool. Okay, I calculated critical value before. Here I calculated the p value. R gives the p value.